How do you get? No, I was asking them to go to the wrong sign. Why this? Why this?
Oh, I know that one. I know that one. Yeah, 2 sine. Bro, I know that one. You know that one.
Not for cosine, but the angle. We have to work it out, the angle.
Oh, why? Because it's going in that direction. It's going in the negative direction. So it's going to be negative.
No, I know that.
So you have.
I said the angle.
Oh, because they gave you -3 and 4, right? So you have your hypotenuse, you have B, so you're trying to find A.
Make it parentheses.
Square root of A squared plus B squared equals C squared. So A squared plus -3 squared equals 9.
So how much time I have?
4 squared.
You have.
Give me 1
Huh?
minus 9.
Okay,
10
good.
minutes exactly.
All right, so I'm gonna go to the next topic. The next topic is double angle and half angle. So I'm gonna start by proving that something we already been proving. We're not giving you something that is come out from nowhere. We're gonna ask you to show you where all this proof come from. But I already did it before. You already see this before. So let's start with double angle. Let's say double angle. Double angle. So double angle is like this. So double angle theorem, double angle formulas. And you already know that which double angle I'm looking for. Sine of 2 theta. Right? So we know that's equal to 2 sine theta cosine theta. How do we prove that? How do we prove that 2 sine theta cosine theta? So it's not memorization. It's to understand what is going on. So this one is 2 sine theta cosine theta. How do I come up with this? I don't? No, it was coming from the other one. It comes from sum and difference. Think about it. If we have sine of theta plus theta, then it's going to be sine cosine cosine sine, right? So it's not memorization. It's just 2 theta is theta plus theta. So therefore you have theta and theta and theta and theta, and that's plus. That's going to be 2 sine theta cosine theta because the order is switch, but 2 times 3 is same thing as 3 times 2. That's going to give you the sum and difference for the double angle identity coming from there. Are we okay here? Cosine 2 theta is what? Well, we know the first one. The first one, if you did the quiz correctly, it's going to be cosine squared theta minus sine squared theta. Do you remember this? And this is the proof. Now, you don't need to know this on the side, but it helps you because sometimes you don't memorize it. You can use the sum and difference, and you can prove it. So it'll be cosine, cosine, sine, sine. And that's theta, 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 theta. That's minus, so it'll be cosine squared theta minus sine squared theta. And that's the proof. You don't have to know this, but it's proof on sum and difference. And we also know this is the first one. There was a second one here for cosine 2 theta. But let's start with what do we know? Cosine squared theta minus sine squared theta. And we can replace one of them with the other one. Remember? Can I replace the cosine? To what? What can I replace the cosine? Well, we know the formula is here. Sine squared theta plus cosine squared theta is equal to 1. Does that make sense? Mm-hmm. And there was a conversion, so that means you can change that to the other way. I subtract both sides by sine. So that's equal to 1 minus sine squared. Sine squared is equal to 1 minus cosine squared. So I can replace this part with this. So that will be what? 1 minus sine squared theta minus sine squared theta. That's equal to 1 minus 2 sine squared theta. Are we okay here? We did this before. This is the second time I'm doing this because a lot of you guys cannot follow what I do. So this one is cosine 2 theta. That becomes the second double identity, double angle identity I want you to prove. The third one is this. Well, the third one's gonna start with the same thing. So cosine squared theta minus sine squared theta. I'm not replacing this one now. I'm replacing this one, right? Benny, pay attention. I'm replacing this one. So this one is equal to what? So it'll be cosine squared theta minus 1 minus cosine squared theta. That's equal to cosine squared theta minus 1 plus cosine squared theta. There's two of them, so it'll be 2 cosine squared theta minus 1. So this is something we know already. I didn't cover anything new. I just show you what do I prove? Double angles, 3 different versions, and then I'm gonna show you what's next thing. Next thing is called power reducing. And I say you don't need to know it for tests, but I'm gonna show you because it's actually not that bad. Power reducing formula is taking this one. So we're gonna take this one. I'm gonna solve for sine squared theta. What do I mean by solve? That means isolating. Can I isolate this? Yeah, I can. So how do I isolate this? The best way is make it becomes on this side and move this to this side and then divide it by 2. So what I'm going to do is I'm going to add both sides by, so that's going to be add both sides by this. So I mean 2 sine squared theta, right? Plus cosine 2 theta is equal to 1. I must subtract it over to the other side. And I'm divided by 2 on both sides. So that becomes the power reducing. Power reducing is useful for calculus. Now, not everybody is taking calculus in this classroom, again, but if you happen to improve a lot between now and next year, then you take calculus, then this is something that you'll use maybe 2 years later in Calc 2. But I still have to explain this because I need to use this to get to a half angle formula. So I'm going to do the same thing. I'm going to do this one. But this one's easier. I'm going to let you do it. Cosine 2 theta is equal to 2 cosine squared theta minus 1. What am I solving for? Cosine squared theta. So that's a 2-step process, right? Adding 1 from each side. I'm going to get 1 plus cosine of 2 theta. And divided by 2. Good. You just find the second one. Moving to 1 divided by 2, and you're done. You're doing high-level math right now. Now we're going to show you how to do a high-level math. So this is power reducing. Why is power reducing important? Because if I were to graph this on the decimal, sine squared theta, and I graph this, they end up to be what? Same graph. But the thing is, what's more impressing is more impressed about the situation is this is a second degree. A second degree function can be represented with the first degree functions, which is that's what it makes math very magical. It's like saying x squared is a parabola. I can use a line, same representation for the line, to do x squared, which is almost impossible. You think about it, but you will be able to do it with trigonometry functions. Trigonometry function. This becomes one of the double angle identity. Now with this, I'm going to introduce the new things. What are the new things? The half angle. Half angle, so I'm going to go move to the other side. We're going to talk about half angles. So we have here, half angle is super easy. I'm going to just look on this side of the board. This is power reducing. We got down to here, we got down to here, right? So we say half angle is right here. Half angle is, instead of solving for cosine squared theta, I'm solving for cosine theta, but one more step. How do I get rid of square here? You square root both sides, but when you square root both sides, you gotta make sure you have a plus minus. Okay, plus minus. Now that's the one part, that's one step, right? And next step is very, very crucial. Next step, you say theta. We know how to find cosine 30 degrees. We know how to find cosine 60 degrees. But the problem is we don't know how to find something that's a cosine 22.5 degrees. So what I'm going to show you is this. This theta right here, I'm going to take this theta, I'm going to divide it by 2. So anyway I have a theta, I'm going to divide it by 2. So what happened? I take this theta divided by 2 and take this theta divided by 2 is equal to cosine theta. So 2 theta becomes theta. Same thing on the other way. It's going to become theta. So it becomes a half angle formulas that you can use later. Okay? And I'll do the video for the last part, but you probably don't have homework on that part, but we can get to homework on Thursday.